Hello, hello. Okay, so checking the sound. Yeah, hello guys. Yeah, looks like I was not online for close to a year. So time to add back some content. So I've decided let's try to do a little bit of Rust. And I was working with Advent of Code on the latest 10 days for the last 10 days. I post on Twitter as well. Um, Overall, looks good. Looks good. So for today, we'll plan to work on the last day, day 10 of Advent of Code. So yeah, let's unzoom it a little bit. We'll make sure we'll make Copilot disabled. The goal of the exercise is to improve our coding skills, so no point in having Copilot on. So usually how I do things, I start the day by copying from the previous one. So let's copy everything from the last day. So day 9, and we'll copy into day 10. Okay, it's not cd but copy. Day 9 and into day 10. And now let's go into day 10. Do a little bit of cleanup. Okay, let's try to go this way. And I'll need, I guess, to switch to this window on my OBS Studio. Where is my OBS Studio? So now let's select day 10. This will be like day 10. Okay. We'll be closing day 11. And let's start digging into day 10. So a little bit of cleanup here and there. Let's check here. Yeah, everything looks good. Everything here looks good. It's unlikely that I'll have at this point in time a lot of people watching, though. Let's see. I would like to follow the chat. Maybe if someone randomly joins, at least I'll be available to answer some questions. So let's find my stream. Live. Yeah, looks like I'm live. Good. And we have on the right side the chat, so I'll try to follow to make sure if there are any questions, I'll be able to answer. Okay, so let's go. Let's go. Start digging into our problem. So first we'll need to go to Advent of Code. Yeah, looks like I'll need to close the sound here on my mobile phone. Yeah, professional streamer, what can I tell? So I have a cup of coffee and a little bit of desire to see what's waiting for us for day 10, because day 9 was quite simple, I would tell. So yeah, let's see. But before that, let's try to clean up a little bit the things here. This is the old input. Solution part, we'll need to clean it up. So very likely we'll not need any of those. Let me make an OK of 1 here. Same here, OK of 1 for this to compile numbers. I'll leave it because this is common usually used to solve Rust problems. So what this stuff does, takes a line and gets the number parsed as an I32 in this example, including minuses. This we don't need as well. So this is for previous sequence, next sequence, blah blah stuff. Example. For sure we'll have an example. It will not be this one. And all the tests besides part 1 and part 2 I will delete, because we will not need them. Okay, so this is the old scenario, so we'll add a new one in a minute. What else do we have? For now, I think it looks good. Yeah. Let me add this. A10. I guess we'll start a timer. So I have a CLI tool which I use to track time. I don't know day 10, the naming part yet. Yeah, let's check. So we'll start a timer once we at least open it. So we'll need to go into Advent of Code. So we are there. We'll need to log in. So let's try to use GitHub. Yeah, I guess we'll not be able to to log in using this stuff. Yeah, okay, so I'll read the problem in another screen. So in order for you to see it as well, probably I'll need to share it. So I guess you'll not see that. I guess I'll need to share the browser. Yeah, let me find the browser session, share. Okay, that will be the browser, and let me show it for you guys. So this is day 10. Looks like a maze or something. Hopefully I'll be able to solve it in a reasonable amount of time and I will not spend an entire night. But let's see. So day 10, pipe maze. Yeah, so let's I guess let's start tracking our time. I'll start the timer using my CLI tool. The name for that will be pipe maze. Day 10. Pipe maze. So we start with this. We don't have this part, so let's read the problem first. You use the Hanks glider to ride the hot air from desert island all the way up to the floating metal island. This island is surprisingly cold and there definitely aren't any thermals to glide on, so you'll leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labeled hot springs, pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine pots are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on densely packed with pipes. It was hard to tell at first because they're the same metallic silver color as the ground. You make a quick sketch of all the surface pipes you can see, your puzzle input. Okay, the pipes are arranged in a two-dimensional grid of tiles. So a vertical pipe, it's a vertical pipe, okay, connecting north and south. Minus or dash is a horizontal pipe connecting east and west. O is a 90-degree band connecting north and east. J is a 90-degree band connecting north and west. I guess that's a 7. 7 is a 90-degree band connecting south and west. F is a 90-degree band connecting south and east. Dot is ground. There is no pipe in this tile. S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Oh my god. Looks scary, to be honest. But let's see. Based on the acoustics of the animal's carrying, you're confident that the pipe that contains the animal is on one large continuous loop. For example, here is a square loop of pipe. So yeah, probably I should zoom it a little bit more. Yeah, okay, so something like that. So dot, as understood, stands for ground. F means, what's F? It's a 90-degree band connecting south and east. I'm not sure I got it, to be honest. Yeah, let's see. What does it mean? So vertical pipe is north and south. So if this will be north, south, south and east. Okay, so let's read more. Maybe we'll understand. For example, here is a square loop of pipe. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. Okay, so what's the difference? So an S appeared. But what's S? S is the starting position of the animal. Okay. In the above diagram, the S tile is still a 90-degree F. Still a 90-degree F band. You can tell because of how the adjacent pipes connect to it. Oh, okay. So this is more like a visual representation or something. So south and east. What's dash? This is the east and west. Okay, this makes sense. So south and east. So they picked specifically this visuals to draw. I guess here this is literally is a square. So we have like a, let's look at the northeast corner. The sketch would instead look like this. Okay, so S in the above diagram, the S style is still a 90-degree band. You can tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. The sketch shows the same loop as above. Okay, so many weird stuff, but it's not connected, so this is the loop. So 7 inside is also kind of garbage. In the above diagram, you can still figure out which pipes form the main loop. There are ones connected to S. Pipes to S. Pipes those pipes connect to. Pipes those pipes connect to. Pipes those pipes connect to, and so what? Pipe form the main loop. There are ones connected to S. Pipes those pipes connect to. Pipes those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to those two pipes. Here is an example that contains a more complex main loop. Okay, so another example. So this is the starting point. I guess the loops goes down here, upwards, and then upwards, L, upward, L. Okay, so this goes up, this goes up once more, and then goes down. Yeah, probably should draw it. That will be a little bit more different. Yeah, literally, this is a very scary problem. I'm not sure what we're supposed to do yet to traverse it. But if it's a traversal problem, then probably BFS, DFS algorithms will help us. But let's see. Also shown. Okay. If you want to get ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Farthest. Okay, so I guess what we'll need to start first is to understand the loop, or we'll have the loop. Or maybe it will be quite easy to find the loop, because every tile or pipe in this loop is connected from two sides. Everyone else is not. So for example, this has no connection from below, so this could be transformed into ground. This is a valid, but this became ground, so this will be invalid as well. This doesn't have connection on the... Oh, or actually it does have connection. Yeah, but that's a valid part. Okay, so kind of have some clues on the algorithm on how to clean up the noise and then to code it. If you want to get ahead of the animal, you should find the tile in the loop that's farthest. Okay, so let's assume that's the example. So furthest, I assume will be this one, because we have like 1, 2, 3, 4. So the distance will be 4 here. Or if you go on this side, this and this and this. So what will be the algorithm here? Assuming we found and cleaned it up, we found but we know it's a loop, so we don't need any algorithms here like BFS and stuff. If you know the starting point, so if it's a circle, we can count the length of this circle, like 1, 2, 3, 4, 5, 6, 7, 8. And then divided by 2, the distance will be 4. So we can count 4 elements like this, 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 and this will be the 4th element here. So probably that would be a way to go. Yeah, okay, so they go in the same way. So 0, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Okay, so these are the distances. So assuming that's the starting point, 1, 2, or 2, 3, 4, or 0, 1, but okay, so going from this direction. Okay, find the single giant loop starting at S. How many steps along the loop does it take to get from starting position to the point farthest from the starting position? So in the middle, or the farthest distance. Okay, so that's for sure, it's a graph problem. That's for sure, it's a graph problem. Okay, so how can we go? How can we traverse it? How can we do it? Okay, let's try to see our input first. But yeah, before that, I guess we'll play a bit with the examples. So which one is our example? So probably we should, yeah, let's look at the puzzle input. Oh, oh my God, this stuff looks insane. Uh, Looks good. Yeah. So 2100. So Chisinau time now. Looks like we'll spend half half a night to code and solve this problem. Anyway, so yeah, let's start work. Yeah, let's get back to our VS Code. We'll paste our input. We'll need a little bit of work to play around with the convention and stuff. But at least we have the input here. Now let's try to get an example. Probably they expect. Okay, probably they expect something more like this to be our example. So yeah, let's get, yeah, let's see. Maybe we'll get a complicated one or the simple one. So yeah, let's get the simple one first. So we'll have like two examples. So this will be the simple one. Yeah, it's fair enough. Probably would be a little bit clearer to do it like that. Yeah, okay, so this should work. Let's go with simple example. And let's copy another one. And this will be a more complex example. More complex example will be this one. So we have the starting point. So let's assume S in our example every time. Yeah, let's paste this. Looks like I didn't copy it properly. Or did I? No, I think I did. Is it different? Yeah, it's different. Okay, so we have like our examples. Stage one, we need to move this code into like a 2x2 matrix. So that will be like a first step which we need to start working on. Okay, so we have starting position, so we'll need as well to have like starting point, and then to start traversing. Traversing using connections. Yeah, and we'll do that. So starting position will be 0. Yeah, I'm thinking, does it make sense to clean it up? Or probably will it interfere? Yeah, maybe we'll have troubles or no. No, because here it's not going anywhere. So still here the cycle goes backwards. So my assumption is if we may start like right away coding it. So we'll start with this. So what's our option? So we can go on the right side. G um, is adjacent to starting position, and we can go downwards. So this will be transformed into something like that. So let me go here. I'll comment it to be it easier. So this will be like starting position 0. We'll go in all 4 directions with an increment, and we'll see if there is a link. So we'll try to go upwards. Does it have a link? No, it doesn't, because this is ground, so it's not a pipe. We'll go left, and we will go right, and we'll go down. Right we cannot go because that's the boundary. Right we can go, and J will become 1. Down, can we go down? Yeah, we can, and this will become 1 as well. And now our recursive function will be here and here. So if we look here, can we go on the right side from this one? No, we cannot. So we can go only upwards, so this will become 2. Usually the algorithms will go in depth, but for the sake of analysis, we'll try to go like more in parallel. So yeah, I mean here will be 3, and then it will go upwards. It will be 4, then this will be 5, then it will be 6, then here wait a second. Yeah, okay, so this will be 6, this will be 7, and this will be 8. 8. Probably this will be 9 if we go that way, but we don't go. Wait, looks like I messed it up a little bit. Yeah, I think it's going a little bit differently. So this will be 8. Yeah, this is for sure, it's 8. Then it goes down. So 8, then it goes down. Probably this will be 9, and then 10, and blah blah blah. But for the sake of the exercise, when we go with this path, this will be like 2. Now this will become 3. We cannot go on the right side, it doesn't work. We can go, this will be 4, this will be 5, this will be 6. It will see that there is 9 on the left, but there is the possibility to put 7 here, so it will replace it with 7, and this will remain intact. So actually we found the loop, because we know that the loop is single. It's by constraint of the problem. So find the single giant loop starting at S. So if we pick S as a starting point, we automatically will find the loop. So we'll not get into branches. We cannot get into the branches. Yeah, but the problem, to be honest, it's tricky. Okay. So yeah, let's dig into code and start a little bit of coding. So we have two examples. First stage is to transform this into something more workable. I guess into a vec of chars, or matrix of chars. How can we do that really fast? I guess it's the simplest way. Yeah, let's just start to write an example, a test for that. And test input into matrix char. So we have this part, and let's resolve it. We'll have a void result for now. Yeah, to not waste a lot of time, probably I'll pick something smaller. I'll pick like this. Let input will be this. And I'm expected as output or grid. Let's call it grid. That will be easy, clearer. So the grid, expected grid, will be a vec of our chars. So I'll go line by line. Yeah, I'll need to spend a little bit of time for the setup of this ports. So next one will be the same. Yeah, let's organize it a little bit better. And let's OK it for the autocomplete to work better. Okay, so next line will be this one. I'm a little bit lazy, so how can we do it faster? Yeah, probably something like this. Yeah, that's a little bit embarrassing. Because you know what? Okay, so let's do the old way, because I'm writing the code for this to be passed. So yeah, let's do the old way. So yeah, we'll need to type. I guess Copilot for this is ideal candidate. He likes to do monkey job coding. But let's say the last one. What's wrong? Okay, I need this. And we need this. So for now, for this specific example, I don't care much on the structure. If it's valid, it's a valid loop or not. I just want a parser function which will parse my input. So we'll write our expect. So set equal read. No, maybe we can do it to grid or gridify. Yeah, let's call it gridify input. And we'll check if it's equal to expected grid. Yeah, we don't have the function, so if you run this test, it will fail for sure. So yeah, let's start gridify. You know that I'm a JavaScript engineer at heart. Yeah, it looks like it doesn't want to add y. Explains in Copilot in line. Yeah, let's edit. What's the problem? Why don't you want to edit? Okay, so greedify will have an input, and this will be an str, and we'll return a vec of chars. Char. Do we need to unwrap or to use something fancy? No. Then we will not care much. Okay, so yeah. What should we do? So first stage for us would be to have it into lines. Okay, so we have the lines part. We'll do a little bit of cleanup. Very likely it's cleaned up already at the input. But anyway, we'll try to do it. So not map, but yeah, probably map will be fine. So let's trim it first. And let's filter empty lines. We don't have any, but I use it as some sort of some idea of best practice. So we have it, and then we map again. After we clean it up, then we'll need to transform it into chars. We'll need to collect it, and this will be like vec of char. And we'll need to collect again, which will be another vec of chars. So that should be our greedify function, which will transform input from this structure into this structure. So we found our grid. Yeah, so we have a working test. Yeah, looks like we have a little bit of clippy errors or issues. Yeah, numbers, I guess we don't need numbers anymore. What's going on? So let's clean it up. So we have our grid. Next stage is to start computing this cycle. Starts computing this cycle. Left, right, boundaries. And we'll need to map like all these markers. We'll need to mark them for us to understand, because logically we understand that this is up and down, so we can go only, so if we start with S, the joint point, or how can we call it? Yeah, probably joint point. Yeah, let's go on a whiteboard and try to draw a little bit, try to understand that part. Yeah, I'll try to switch to my drawing board. And see a little bit of examples on how can we understand this structure. So yeah, we have our drawing board. So assuming we have a starting point and we have a down. So starting point in our case. Actually what they wanted from us is they choose the closest semblance for the figures to draw like a square or a path, a cycle. So if maybe someone of you which didn't understand and will rewatch it later, if we go, I mean, it will be kind of hard. How can I do it? Maybe I can print screen. Yeah, let me try to print screen this. Selection. And try to paste it into this. Looks like it was not a good idea. Why? Yeah, I didn't print the stuff which I wanted. Yeah, a moment. Maybe I'll try like this. Copy this. Okay, so this is more like it. So we have this example. Is it visible? I think it should be. So when we have like the starting position here and goes down, so starting position, I guess, should be an F. An F because it symbols with these structures, like a corner. It has this F part, which is a little bit weird, but has it. So this is our starting position. And then it goes down. So this is a clear pipe down. And then we have another part of the corner. So we have this one. A stuff which goes back and upwards, nothing closer in semblance than a J. So this will be like looks like a J, and then an F again, but without the F part. And then we have two dashes. Yeah, I'm talking about these two guys. And then again we go from back to up. So we have here 7. So 7 will be this part. And I guess, oh, wait. So I'm a little bit confused how we go. Okay, so this will be J. So this will be like our J. This will be our 7. But what will be... so it will go... Oh, okay, got it. So now we'll go into L. Yeah, where is that color? I guess this one. So now it will go into L. So this will be an L. I'll mark it with a small L. And then goes upwards, this one. And then it will be like, let me use other color to be clearer. So this is upwards. Then we go into 7 again. Then it will be F. Then this part it's J again. And then it's, I guess this two connects. So that's the loop. So yeah. Okay, so we drew it a little bit to have a clear understanding of what's going on. But now what we'll need to code the following structure, because let's assume we have an F. So F has connections only to bottom and right. So that's the possible ways on where we can go if it's a pipe. So if you put F, it will be like a bottom and right. Bottom right. This is what it connects. Pipe will go up and down only. Yeah, probably will go like northeast, but bottom right we'll check. What else? L will have up and right. Up and right, because it has a connection up and on the right side. If we go with J, so J has up and left, up and left. What else do we have? What's a 7? A 7 in our case, it's down and it's down and left. Down and left. Do we have anything else? And we have dash, which will be like right to left, right and left, or left and right, both equal. And I think we covered all, we covered everything else. So if we go here, if we found, for example, we traverse our tree, and we found an F. If we found an F, then from this F, the possible paths are bay or bottom and on the right side. Either we go down, I guess not bottom, but let's use the same terminology. It will be like down, or on the right side. If you found this pipe, we can go either upwards or downwards. Upwards or downwards. If you go this, it will be upwards or right. If you go this, will be upwards or left, either up or on the left side. 7, down or on the left side. And here, either right or left. Okay, so we kind of we have an understanding of our paths. Have an understanding of our paths, and we can figure out, I guess next stage will be to find a starting point. So we need to find the start. So yeah, let's write a little bit of code to find a starting point. Okay, so part 1. But probably before part 1, we'll need to do some more manipulations. A little bit more manipulations. Maybe we should code the path or our map. Yeah, probably that's a map which I defined in my paint. We should code it somewhere, at least to have it. So I'll write it as a comment for now. But our inputs are the following. So we have like F, and this will be like down, right. We have a pipe down, this will be like down and up. We have L, which will be like down, left. We'll have J, which will be like left, up. We have 7, which will be like down, right. I'll have minus, which will be like left, right. Do we have anything else? So 6 points. Yeah, it's only 6. So we have everything here. Let's make a mental map for them. Okay, so what does it down mean? So down, if you're looking into a grid, we'll manipulate a grid using like 2 indexes, like I and J. So if we call like I will be the 4. So actually there are two for loops. So for I, blah blah blah, length of the grid. For J, blah blah blah. If you want to go down, actually what we'll do, we'll increase our I with 1, because we are, let's assuming we are at here, F. So if we go down, this means I plus plus. If you want to go up, it will mean like I minus minus minus, but we don't have this in Rust, so it will be like +1 and -1. For left, this means we'll increase J. For left, we'll decrease it, and for right, we'll increase J. So that's how we'll be operating this grid, and the way how we'll be traversing it. So there are no traversals or stuff like that, where, let's say, tricky operations, because for each stage, if you got an F, a starting point, then we can go two ways, or let's say 4 possible ways. But in our case, there will be only 2 valid. What we want to tell, so if we have an S, we don't know what S is. Could be either of all of this, but we know that this is a valid loop. So if S in our case, we should try to go on the right side. Is it a valid item on the right side? What does it mean valid? we need something which has an opening for the right side. For example, 7 could be a valid one. I'm not sure about this. Yeah, probably not only this we need, but we need a direction to know it. Because, for example, on the right, we cannot expect 7, or do we? No, we cannot expect 7. On the right side, we can expect only compatible stuff. Okay, so on the right side, we can expect, if you go on the right, then there should be something that has a left opening. So this comes in pair. So if, for example, we have 7, so let's assume we start with 7. So 7 has an opening to down and right. Then compatible things would be something which has a left and something which has an up. So what stuff? It's yeah, but also down and right. Yeah, okay, so this is possible. So compatibility stuff. If we go with this understanding, pipe will be, because we have upwards connection compatibility, and we need left compatibility, something which has left. But why this is L? It's like not down and right. I think that's not correct. It's up and right. Up and right. J, it's left and up. Okay, that's correct. This is down and right, or right and down. That's also a way to look at it. And minus is left and right. Okay, so a small correction. So compatibility stuff with F will be pipe, and stuff which contains left. Stuff which contains left, it's dash. Yeah, could be dash, because it has a right opening, or right interface, we can call it. This has like for the right stuff. And what else do we have? Left opening could be J. Yeah, J is possible to have it, because we have like up interface. What else can we have? So down we need up or left. Left we have 2, J and minus, and up we have L. Yeah, we have L. So L is also possible to have it. Yeah, okay, got it. So we have L. So from F, there are 4 possibilities. It's either this, minus, but yeah, we kind of need to know the direction. My god, this is quite complex, to be honest. Yeah, but we know the direction. Because if you go with F, but we want to go on the right side, we cannot have a pipe there. So this assumption is not totally correct. So it's also dependent on the direction. So possible direction for F will be like down and right. Okay, so I guess mapping will be a little bit different, not like that. So we have F. So yeah, let's go with F. Then we have 2 possibilities here. We have like down, and we have like right. because we have an opening down and right. A connection for down is stuff which has up, and this could be like a pipe and J and L, I guess. Yeah, it's possible. So you have like some sort of square. So these are the possibilities, compatibilities. If we have found an F, if you go down, for the next items to be either this or this or this. If you go right, right means we have the opening right. We need to see openings with left. So this will be a J. What else does have left? Or a minus. Wait, this has down and left. 7. Yeah. Okay, so this goes down or right, down or up, down, up. The connections, possible connection. This will be connection up or right. This will be up or left. This will be like down or left. That's correct. And minus left or right. Okay. Okay, so the entire problem then it's a big match, I assume. Because we'll need to we'll need to map it. I did not see it, to be honest. I did not see like a clear fast solution for this. Not like a clear fast solution, but a clean algorithm. So yeah, probably we'll go mess it first, and then we'll try to get somewhere. Okay, so first stage, let's fastly find our starting point. So we got like our input. Let grid, we'll have like gridify input. Now we have our grid, then we'll need to find I and J, or the starting point of our S. Start will be like S. Yeah, nothing fancy here. For I in 0, read.len. For J in 0, is it a square grid? I don't know. Is it a square grid? It's not written. Yeah, let's check in the documentation. It doesn't feel like it's a square grid. Yeah, let's check. Square. For example, here's a square loop of a pipe. For example, with the square loop. No, it's nothing written that that's a square grid. Scanning there is cover, blah, blah, blah. Okay, so is it a square or not? Actually, in this example, it's a square. So we have like 5 columns and 5 rows. Do we need to expect that this will be a square? A two-dimensional grid of tiles. Okay, whatever. To be sure, I'll just do it the old way. We don't need to be specifically fancy for that. Okay, so let's get like grid of 0 of length. We know that the grid is valid, so that will be the fastest way. So here it will be like n, here it will be like m. Fast check if grid of yj equals start, then okay, let mutable start point I'll just assume that the starting point is 0, 0, but for sure it will not be this one. So starting point will be start point of will be I, and start point of 1 will be j. Is it mutable? It is. Yeah, so we have a little bit of code to find the starting point. And so at least we found the starting point. Next stage, what we can do, we can already mark it with the distance, I guess. So we'll need a distance variable. Okay, so let distance, we'll start at 0 and we'll increase it from time to time. Okay, so this will be starting point. So grid of I j equal distance. What? Okay, so our grid, it's should we make it as a char? That's maybe we should make them strings. Yeah. Okay. That will be like a nightmare with the types. But yeah, actually, let's not pollute existing example. Let's make the let's make a clean grid or a numbered grid. Let mutable numbered grid will be the same grid. It will be like a vec of 0 m, I think, and n. So our numbers grid, so we'll go this way because it's equal. It will be a copy of the main grid, but will not pollute it. We'll keep the numbering all in this numbered grid, but we'll operate on the main grid with the chars. So distance, numbered grid. Yeah, this is pointless because we have like already it's initialized with 0. But let's keep it for consistency. Now we can break this loop. Now we have our starting point. We can start our operation. So from starting point, we'll need to go up. We'll need to go left, down, or right. From all this direction, we know for sure that only two will be valid. Could be up valid, could be left valid, could be down valid, could be right valid. And what the validity mean? This means that there is a char there which satisfies the interface. So if you go up, then there should be something which will satisfy our up interface. Something which has a down, like F, or another pipe like that. Stuff like this. Okay, so how should we manage? So we didn't know in which direction to go. But actually the direction will be chosen randomly. So we'll have current step, or not step, but current position. And the current position will start at starting point. We start with the starting point and then try to go up, down, left, right. And if we have like a valid item up, down, left, right, then we'll continue in this direction. This is tough a little bit at first for the first, because we don't know what the item is exactly, so we'll need to guess a little bit. We can infer that this is an F, but for us it's marked as an S, so we don't know exactly what's going on. So yeah, okay, this will not be, it's not needed to be mutable anymore. Distance. Distance, it's useful for us because once we go to the next item, we'll increase the position. So we try to find a way, and the way will dictate itself. Because we don't have branches, we don't have anything very specific. And sorry, hello everyone. Yeah, I've noticed. This is Rust language. Yeah, entire week they gave like bullshit problems. And this one, it's a little bit more interesting at least. So yeah, and the funny part is we'll have like a loop. We'll loop changing the current position until current position will be equal to start position. Current point, okay, so let's see, point, call it to be more. If current point will break our loop, this means we close the loop. For all the other cases, I guess for us, we'll still need to figure it out in which direction to go. Yeah, because this is a problem. This is the problem. Let me show you what I fear. Okay, let me show back the whiteboard. Okay, let's show the whiteboard. Okay, so we have our whiteboard back. Yes, let me do a new canvas, but probably not. I think I can leave this one for now. So imagine we are in the center. So imagine we are here. We start with S. I need a color. Give me please a color. Okay, so we start here. Then we are not sure which direction will contain the right loop. That's the problem. Because we may have like but we're not. No. In either case, if you go up, down, left, or right, No, but it can be. It can. How do we know which stuff it's yeah, the trouble is to understand which letter is S. Because S for us will be like a question mark. We don't know which. If I knew that S automatically become an F, the problem is quite straightforward and easy. But we don't know that. We know that S is part of a loop, the biggest loop. But which one is the biggest loop? Probably they want us to find all the loops first. And then find the item at the half of this distance, because it's a loop, so it will be like half of the distance. So let's assume we go upwards, so it's ground. Okay, so then our loop. Okay, so in all the cases, if we start with S, there are 4 possible loops. One which goes up, one which goes down, one which goes right, and one which goes left. We try to go up. In our case, it's ground, so automatically this loop is not valid anymore because couldn't be a loop. Left, we cannot go because this it's a boundary, so it's all just on the left side. I mean, it's a boundary on the left side. Down, can we go down? Yeah, we do. So we have like 2 possibilities. So by elimination, we found the 2 loops remaining. But once we got like 2 loops remaining, we know that these are 2 ends of the same loop. The question is how we should eliminate the other 2, because we don't know. So probably we should go in all directions and try to figure it out. So yeah, assuming we go in all possible direction, we increment with 1, with 1, with 1. We found out that this it's ground where it cannot go anywhere anymore. We drop it. We drop it. And we go with the other 4. So yeah, let's try to go in this. Try to code this, and we'll see where we'll get. So yeah, let's switch back to our coding board. Fortunately, yeah, it's not a good start. So yeah, we'll have like a. But how should we mark them? I don't even know. To have like 4 different loops, maybe. We know that we need to go up, down, left, and right. Okay. Or if you go like with an BFS algorithm, not BFS but DFS. So we go like a DFS till we found. Yeah, I guess it's a DFS algorithm we'll need to implement. Depth first search. And what do we do for DFS? We need to use a stack. Okay. So I guess first thing which we do, we'll have a stack. We'll initiate the stack. Okay, this will not need. Okay, for now, stack. Yeah, probably have different DFSs. Okay, anyway, so we'll initiate our stack with push starting point, because we need to have something in the stack. Then we'll while stack is not empty, we will pop the stack where current point will be stack pop. But actually, no. Actually, in our case, stack. Yeah, probably we should do like depth first traversal for all possibilities, like up, then bottom, then right and left, to have it different approaches. So then let's assume we'll go up. So starting point will be this, and let's try to not. The idea is like we'll try to go upwards. We'll try to go upwards, and then the current point, where the starting point will not be this anymore, but will be like a start point. Up point, let's call it up point. It will be like start point. If we want to go up, this means we'll need to decrease first item -1. Yeah, but we'll need to check for boundaries, because this can be problematic. So up point will be like this. Okay, let's check this. If start point of 0 -1 is greater than 0, yeah, let's go this way. Then we'll do like up start point of 0 -1 and start point of 1. If it's greater. If it's not, then we cannot move upwards at all. So we need to deny this. Oh my god, for sure I'll spend the whole night with this. Okay, so I'll go breathe some air, 5 minutes, and then I'll get back and try to finish coding this problem. Okay, so I'm back. Kind of, I figured it out. What's my trouble? Yeah, we need, besides the point itself, we need in our stack to have our direction. So we need kind of a struct in such form. We'll need something like this. So I don't know, maybe we'll create a type or a struct. Let it be a type. Point dir, which will be like a new size, use size, and a char, or wherever, and then dir direction. Let's call it, or it'd be like left, right, bottom, up. We need this for the compatibility stuff. So our point direction will be like, yeah, probably I should do it like this. And then direction, whatever. Maybe something like that. So maybe this is our structure. Okay. So if we have this, we need to initiate our stack. So in order to initiate our stack, we'll go in all four directions. We don't know which one will be the highest and stuff, but we'll need to initiate with the highest direction. So if we have starting point greater than 0, this means we can go upward. Then we'll create a point, which will be like our point with direction, which will be like start point of 0 minus 1, start point of 1, and the direction will be direction up, as we're going up. I'll need this part. We'll need this part to understand our interfaces. So we'll push this point. Let's push this point. Okay, so then we'll need to do all the other 4 other boundary checks and add in our stack the other things. So if a start point of 0 is less than n, and it's our less than n minus 1, I guess, because we need to make n plus plus. This means we go bottom. So we'll have this. And we'll go bottom. So bottom, this means +1. Yeah, it's a lot of boilerplate code, but I think we'll get somewhere. Yeah, we'll need to figure it out with the distance. But at least we go in some direction, and yeah, we'll need to make sure that this goes down. Okay, so I guess not be like down. Direction down. Yeah, let's go with the J. Left and right. If start point of 1 is greater than 0, then we can go left. This means this will remain the same, but this will go -1, and this will be left. And we will need to check for boundaries on the right side. is less than m minus 1. This will be like right, and we'll increment it. Okay, so we have like our stack with 4 potential points. In our case, it will not be like 4. So yeah, probably we should print our initialized stack first to understand. What's wrong? So stack, what's the problem here? Oh, so debug. So yeah, let's derive debug. Yeah, actually we don't need regexes. And this it's with uppercase. Okay. Yeah, okay. So we have the following stuff. Simple example. Yeah, let's try to run it. So we have potential possibilities. It's up, down, or left. Up will be 0, 1. I'm fine with that. Down will be 2, 1. Yeah, something is not right here. Let's double check that. Yeah, wait a second. So 0, 1 goes up. Yeah, we'll need a starting point to have an understanding. It's 1, 1. So, okay, so up, it's 0, 1. Down will be 2, 1. Okay, correct. Left will be 1, 0. Oh, so I guess in this case, we're looking at this example. Okay, so it is a possibility, correct. So simple example. We're not using the complex example. So that's correct. Everything is fine. Good. So we initialize our stack. Now we'll go in depth. What this stuff means? This means we'll need to push into the stack all the points. So the current point will be one of those. We don't know which one of them exists at the moment. But what we'll need to get, it's let item. We'll need to, it will be like read. Let's do this a little bit different. It will be like car point, car p, and gear. And I guess IJ. I don't know, it's a little bit weird. Yeah, you want me to unwrap it or whatever? Let's unwrap. Direction and point. Let's go this way. That will be clearer. So we'll get our item, and this will be like a point of 1. No, 1 point of 0 and point of 1. So we got our char. Then we'll need to match our char, our item. So we have the following possibilities. we'll need to write our list. But yeah, actually, we shouldn't do it like that. We need to match direction first. So let's match the direction. Yeah, a moment. Let's match the direction. So we have the following possibilities. Please add the matching arms. So we have like left, right, down, up. Yeah, we'll need to fill in some code here, because the goal of this, we'll need to check if it's up. If the direction is up, we'll need to figure it out if it's a valid construct. So yeah, let's go with that first. Just a moment. Okay, so yeah, let's try to move on a little bit. So if it's the direction left, what do we have for left? So if it's a left, then we'll need to find things which are compatible with left. Probably we should do something like a map of these things. In the form of something like that, like I don't know, compatibility map. And compatibility map, where, and this will return like a hash map. I mean, it's not really a hash map, but wherever. So we'll introduce a direction, and we'll get back a vector of possibilities of chars. And this will look something like this. So we'll have a tuple direction, for example, direction left, and the possibilities for left. Yeah, we'll need to map it. Okay, so hash map new. So what's the chars possible for left? Left means we need to find right interface. So this will be dash. Or actually we can call it a sat. Let me do a small check. Yeah, let's check this here. Probably it will be easier. Contains. Yeah, I guess it's not an vec, but it will be a hash set. Hash set of chars. Because I need to find if it exists in that list. Okay, so we have this dash. We have for left. So we need right stuff. If you go left, could be J. If you go left, what else do we have? If you go left, no, if the direction is left, so we need right stuff. Okay, so F will be could be L, could be minus, so or minus F and L. Oh, yeah, what I'm doing, I mean, it's I don't even need that. Maybe it's a string. Yeah, I guess I'll do like string in this form to not spend another half day to figure it out with because these are chars and it's one character, so it's like minus L and F minus LF. Okay. And then we'll do iterator and then collect, or maybe easier will be like that, this hash map from iterator. And yeah, I guess let's call it an iterator. What's the trouble? Oh, to string, I guess. What's the other trouble? Oh, we need to compare. Yeah, okay, so did it work? No. Okay, let's do like this. 0, 1, 2, and 3. Okay, right. I don't really need something specific, but I need something to help Rust to partial equal or equal. Trade bound direction hash is not satisfied. So what do we need to implement as well? Derive hash. Okay, so now did it work? Into. Okay, so now we have something. Now we have something. It's not very good, but anyway. So yeah, let's finish our mapper. Yeah, we go with the right. If it's right, we need left. So if we go right, we expect J. J minus and 7. J minus and 7. Let's go up and down. I don't know if we need like this as a hash map, maybe as a matcher. Yeah, I guess that'll be, we don't need anything. So for compatibility, and it will provide the direction. Because it's too complicated. I don't think we need any of that. And instead of all this, we'll have like a matcher function, and it will return an str or a string for us. Match dir. Tail matching arms. For left, we will return this minus lf to string. Yeah, we can even try, but yeah, it will not allow us. Yeah, we don't need this, it will be just a string. And this, it's useless, we don't need that. So yeah, just let's type in all the other possibilities. Right, so right, we need lefts, j minus 7 to string. If we go down, so we need up compatibility. So it will be L pipe, L pipe, and J, L pipe J to string. Is there anything else? No, I think it's only three each. And here will be direction up. If we go up, so we need something down. So we need F's, F pipe 7 to string. Okay, so we have like a compatibility map. Compatibility dir direction. So we have this. Will it allow us to go with just str, reference of string? Maybe we can go like with static and it will allow us. Okay, so it does allow us. Good. So we have this. Here, we will not need to match it because we'll have like item, and then we'll have like if char, or not like this, but compatibility dir of dir contains char item. This mean that we can increment our distance. Yeah, but we'll need kind of to understand the direction. For that, we'll need to figure it out. Okay, anyway, we'll increment it because we'll need to increment it. Maybe we should keep the distance into the point. I guess like that will be clearer to maintain. Yeah, usually we'll need a recursive function, but another use size. Yeah, it's a weird structure. But here we'll have like everything starts at position 0. Otherwise, we'll not be able to understand the count and where does it come from. Okay, so this makes more sense. So we have direction and distance. distance. So distance, what does it mean? Yeah, but this will not be like zeros anymore. This will be like ones, because we moved one position up. So yeah, we move in all directions. If item contains, what is it, the compatibility dir contains item? This means that our direction is compatible. So we can go this way. And this means that in our grid, our numbered grid, of point of 0, point of 1, we'll put our distance. This is what it means. Now, from this point, from this this part, we'll need to find the corners for the item and add the new points in that direction. And this will be something like this way, but it will be like a matching function. It will be like some sort of a matching function. So we'll need to match possibilities, I guess. Yeah, let's try something like that. I don't know. Yeah, I guess the point here we'll need to match the item. We'll need to match the item, and we have like f here, and we'll need to find like 2 points. Actually, not 2 points, because we have the direction. So for f, we'll need to find the right direction, right corner. Oh, yeah, we will still need to match it. So it will be like a match. So okay, so it will be like match of direction first, and then we'll need to match every time item, because we know the direction. But for f, we'll need to go to find if, for example, we come from left. Yeah, but it cannot be actually f, so here it will be a limited amount. Right. Okay, let's go one by one. Yes. Match direction, and here will be like next point. So we'll create a point out of this match, and we'll push stack the push this new point. I'm not sure if it makes sense to call it point again. But let's try. So let's assume we come from left. If we come from left, then in our grid here could be like wait. If you go left, oh, okay, so it could be F. Okay, so if it's up, then the direction will be down specifically. So we come from left, this will be the right corner, and we go down. So our point will have like yeah, first we'll need to do this down check. Yeah, probably we shouldn't call it like point. Maybe next point. So we need to check for boundaries, otherwise we may get into troubles. So for down stuff, specifically for down, we need this. We need this spot. And this will be like a just point. And this, should I go with like that? I don't know, maybe I'll go with like this for now. Return it like this. And this will be like direction. Not direction, but distance. +1. Because we go in the next way. And here I guess we'll need to check if this is the shortest, then already in numbered buried, then now wherever, I think we should keep it for now. I just want to see where we'll get. Oh my god, such a weird problem. A lot of code. Okay, so we if it's direction left, could be one of those. This is specifically down if it's up. We can have what else can we have? We can have like panic. Shouldn't match this on. Okay, so let's double check here. So we go down, but not starting point, but just point. And distance +1. Okay, so we kind of, that's the way to go. Next point. Let maybe next point, that will be more like it. Some, else none. Yeah, I feel like this will be like a lot of boilerplate code. I don't necessarily enjoy having. Okay, so something like that, and here if let's next point equal maybe point, that push next point. Direction. So what don't you like? Use a value of moved value dir. Yeah, okay, got it. So let's have it like that, because I don't need specifically here this. Okay, so we've got this part, then we'll need to write, for sure we'll need to refactor because this looks ugly as hell. And we'll need to write tons of other matching plots. So, okay, so we got F. What else do we got from left? So we need to write matching arms for these pods. Yeah, F, let's write for minus. Yeah, what do we have for minus? So if it's left, we come from left, then the marching part will be right. This means we'll need to check for right part. So this will remain the same, but not point of 1. We come from left. Yeah, I already got confused. So okay, so we here left and we have F. Left, this is the matching part. We go down. So left, this is the matching part. We go right. Okay, so we need to go right. So direction, next direction will be right. Distance will be this, and here. Yeah, probably should write a boilerplate code for that. Yeah, let me write some boilerplate code because this gets ugly. The more I look, the more ugly it gets. So I need to go up. I need to check this. And if I need to go down, so I'll have something like I need a function. Okay, so I'll need a function which will produce a point, or maybe a point. Yeah, let's call it maybe point. Yeah, so let's produce a function. Maybe next. Yeah, actually, it's a little bit ugly, but maybe point. Which will contain current direction. Do I need current direction? No. I need the next direction, or next direction. I will need current point. I will need and an m. And I will need distance. And this will produce an option of pointer. An option of this part. Option of this part. Because yeah, otherwise this will get insane. So next direction, this will be like a direction. Current point will be like an usize. And it's a new size. It's a new size. And distance, I think it's a new size as well. Or I32, but a new size, I think. So we got everything. And what we'll need to do now, get this logic. Yeah, I'll copy it for now. Put it here. Here it will be like current point. Yeah, but we'll need to match it. Okay, so match next direction. Okay, fill matching arms. So if it's up, so we need this code for up. Yeah, we don't need this. This will be like distance. I'll make sure that I'll increment distance somewhere else. So this will be this. else none. Here it will be some. Or none. Yeah, so I'll need to write all the other matching parts. And we'll reduce a little bit of boilerplating code. Okay, so this goes. Yeah, probably should do it like this. Yeah, okay. Let's implement the others. So for down we have this. So this will be like current point. And we have like some. Have this like some, or we'll go the none. And distance will be distance. Probably here can do like this. And probably here we miss, I think, a semicolon somewhere. Okay, let point. I'm getting confused. And some point. Okay, so we mark this part. Yeah, let's go right. Implement the logic for right. I guess this will be the logic for right. And here right, and make sure it's a new distance. Remove this and some point, else none. And the last matching arm, left. It's this stuff remaining, left. Okay, so we have this current point, direction, distance. This we don't need, some, none, comma here. It looks like we have some troubles. I'm not sure what exactly. The remove semicolon returns this value. Oh, so you want me to remove it? Okay. Fine. I'm fine with that. So yeah, we have like maybe point. Now what we can do is instead of this code which is duplicated, we can have something like this. Let we have like a vect. Okay, so let's initialize it in this one. So we'll have like maybe point. We go up, direction up. Current point will be start point. NM is this, distance will be 1. Or we go down. Or we go left. Or we go right. But all of them are, we can have like into iterator and flatten. Let's collect. So point here. Okay, so we have our stack written in a little bit cleaner form. So we don't need this. And now this, what does it mean? This means like we have our point and we need to go down. So this will be like maybe point, direction down, point, and distance +1. Okay. And this will be like same, but direction right. Direction will be right. Okay, so now this becomes a little bit more clean, let's put it this way. So what's the matching guard remaining? It's L. So assuming we come from left, then the matching guard will be up. Maybe point, direction, up. And we have the other things, the other goodies. Yeah, we'll need to debug this stuff. It's insanely interesting. Okay, so we have written what happens if it's left. We expect some of them. Then we'll receive this point. If this point may be next, then we'll push into our next point and we'll move further. Okay, so we'll have our stack there. Yeah, let's write the other matching items. So again, match item. Our possibilities for right. What do we have for right? It's these ones. So it'll be J. Yeah, we'll need to write this first. Okay, so if it's J and it's on the right, we go up. So maybe point up. Yeah, probably I should do it like this to even reduce a little bit more. Yeah, let's do it like this. Let up. Up. Then we have down. Direction down. Then we have left. And then we have right. And this will be like this will be like up. So it'll be like right. So it'll be like down. Coming from the left, goes up. Yeah, now it's a little bit clearer which direction to go. So we'll map it faster this way. Okay, so we come from the right, so we go up. Minus. We come from the right. Wait a second. It doesn't make a lot of sense. I'm confused the hell out of me. So is J this stuff? How did I get into? Right up. Right, and then we go to left. Okay, so this makes sense. What else? 7. We go to right, we go down. Okay, finally we did this as well. Let's go next. So we go down. I guess like this. Let's go like this. Match item. Okay, L. If you got L, so yeah, let's go with panning first. So we'll go down, then we'll go right. Down, then we'll go right, and the direction will be down. That down, wherever. That's weird. J will be left. And last one. Okay, so if this is the last one, yeah, let's see what do we have. So this free. Okay, so we got F. We go up, then we'll go right. We go up, then we'll move on upward, up further. If it's 7, then we'll go left. Cool. Okay, so we've got everything. And let's try to run it and probably print numbered grid. Yeah, I don't really like what I've got. I don't want it like this, so probably yeah, let's not try it with this. Let's try it like that. Wait, something is not right. Yeah, I think this I need to run. Okay, so we got 1543000. Yeah, I'm not sure, this example is weird a little bit. Yeah, let's keep it. Let's try it with the more complex one. I'll just call this an example and that's it. Yeah, let's go with the debugger, I think. It's very likely we have some issues somewhere, but at least we'll know the state of things. Okay, so debugger, debugger. So let's see. This is our grid. Yeah, I need to unzoom it a little bit. Yeah, let's go on this way. So again, yeah, we have written tons of code and I have an impression that we are lost a little bit. Okay, so things which I need to check first, it's the stack. So I want to see what do we have in the stack. So we have like 3 points. I'm expecting up, down, right. Yeah, we cannot move left because we are in the boundary, so that's correct. Everything looks nice so far. So yeah, we got the current item. So what do we have in the item? Yeah, we'll have it here. So it's in J. We check the compatibility grid. Yeah, it contains. Then we mark the numbered grid. So let's put the numbered grid here. Oh, this looks so cool. Okay, so then we have like 01, which is correct. Now we have our functions, blah, blah, blah. We don't care. Actually, we kind of may move them a little bit upwards. Yeah, to not generate them each time. But maybe next point, we need to find the J. And we come from, what's the direction? Right. So we come from right. So I'm expecting, so we come from right. I'm expecting to go up. Yeah. So we found the next point and we push, we move up. Okay. Okay. So far so good. So now we should have an increment here. It will be like 2. We got our item. We check the compatibility. Yeah, there is a compatibility item there. We get a distance, and our distance will be 2. And yeah, we marked here 2. So far, we're good. We have this, which I don't like, but it's fine. What's the item? F. F and the direction. What's the direction? Up. So we should go right now. So I'm expected to go right. Yeah, okay. Good. We move right. Found numbered grid. So we put the 3 in our grid. Yeah. That's correct. Yeah, let me move all this garbage down. So we have a 3 here. We have the steps. What's the item? It's a J, and the direction it's right. So we go up again. So we go right and up. We check the compatibility again. We put a 4 here, and I assume we'll need to go right. So up. Yeah, it's right. Yeah, so far we're going very nicely, I think. Six, so we move down. Yeah, let's see. Seven, and now it will be right. Okay, so we got 8. Yeah, so far we're moving very nicely, the same way as it's expected from us to have from our example. But I would like to see as kind of we'll need to. I have an impression that we'll cycle here for a while. Okay, so let's see, 8, 9, 10, 11, 12, 13. It goes back. Okay, so oh my god. Yeah, kind of we need to to tell that we went this path. We'll need to mark the visited numbers, otherwise it's it's weird because it went through our path like the direction 1, 2, this way. It went to the final stuff. Okay, I guess let me show you once more. It will be clearer. So we have our numbered grids. So we start everything with 0, 0. And then you see like we go right, then up, right, up, right, down, down again, right. Here we go down again. And instead of like moving down, it moved to right. Okay, so I'm fine with the right part. But it goes backwards. And goes backwards and increment everything back. So probably we shouldn't. I didn't. I'm not sure why it did go back. Because maybe it's a bug actually. So what do we have here at 10 and 13? Yeah, what do we have at 10 and 13 stuff? Is it this too? Oh, here left and right. So it went back instead of moving on the right direction. So it's a bug. Okay. Okay, so we found our bug. This means that when we have like minus, we come from the right and we go to the left. Okay. Wait, what's the bug? Okay, let's check here. So here we move. So if it's left, we move left. Right, we move right. I don't get it. So we come from left. We come from this side. Then we'll move right. Okay. If we come from the right side, then we'll move left. But left means left. Yeah, that's weird. Let me debug once again, because it shouldn't go this way. We should do a full circle and not go back. So yeah, let's go with the debugger again. So debug. Yeah, let's go this way. We know that it will spend some time. Man, I already need to start again. One, two, three, four, 5, 6, 7, 8, 9, 10. Okay, so we are at 10. What's the direction? Do we go with the compatibility dir? So the direction, it's right. Wait, but why it should be right? What was 10? Yeah, let's look again. What was 10? So 10, it's minus. And J, it's we come from upwards and go should be left. So we, somewhere on the J we have a trouble. So if you come from up, come from down, yeah, let's look at J's. J left. I don't get it. What's that? Why? 11. So why we move to the right? Who decided that we need to go right? Yeah, try again. Debug. Nine. Okay, so here we start to have troubles. So it's a minus. And let me have the direction as well. So it's left. But why? It's not left. 9. So it's a minus somewhere. We have some troubles. Yeah, let me see. Where is the trouble here? So we have two possibilities, left or right. So if this comes from left, we go to right. But wait, it won't be left. It will continue to be left. And this will continue to be right. Because we keep the direction. Yeah, that was the trouble. Okay. So now it's a little bit clearer. So yeah, let's check again. F5. Okay, 11, 12, 13, 14, 15, and we are done. So we found our cycle. And this is the biggest cycle, and we were lucky to find it right away. In stack, we have 2 more branches to check. 1, 2, 3, 4, 5, 6, 8. Yeah, this is the other one. Okay, that's clear. And the last one, it exited right away. Okay, so we have the numbers. Now we kind of need to find the middle. And how we should do that? I guess I should find the max in the half. Okay, so in either cases, we will have or one or the other. Yeah, let me do something like this for I in 0 n. Print line. Let's go. Okay, let it be like that. Grid numbered grid of I. I just want to see the results. Okay, so either this way or that way, 8 will still be in the middle. Because we have like a buff of 16. I spent a little bit more time, but it doesn't really matter. Because still we have like 8. But what's expected from us? This is what we need to check. What should we return? Find a single giant loop starting at S. How many steps along the loop does it take to get from starting position to the point farthest from the starting position? Oh, so I guess we have the max and we divide by 2. And that will be our answer. But maybe we can keep the max to not do weird operations. Maybe we can keep it. Yeah, probably we should keep it. So let's keep the max. Maybe max distance. 0 to not spend any more time. And I guess where do we do our magic? We do it here, and we'll have like max distance. Will be max distance, max of distance. So here we'll keep our distance, and now our response will be divided by 2. You know that's the right, maybe max distance plus 1, because we started with 0. Yeah, let's try that. Let result. Okay, of result. But it's expected what? It's expected an I32. Yeah, let's make it an I32. So we have this, we have that. So probably here we should put an 8. And it did work. Okay, so we found this. Now let's try, I guess, the big one. Carbon test. Yeah, solution part 2 for sure, it will not be like this. We don't know what the solution part 2 will be. Cargo run 6903. I hope this to be my answer and go to sleep. Because this was not a fun problem to solve. Okay, so let's try. Let's try the browser. Actually, not the browser, but let's switch to the browser. And we our answer is 6903. We put it here, we submit, and that's the right answer. You are on 1 gold star closer to restoring snow operation. Okay, so we are 1 gold star close. Status. So we have like close to 3 hours working on this problem. So the guys who will watch this stream, I'll probably put some points here and there to have some ideas. Okay, so more insanity. Oh. Okay, you quickly reach the furthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. For example, the above loop encloses merely 4 tiles. What? I don't understand. Merely 4 tiles. The 2 pairs of in the southwest and southeast marked I below. Oh, okay. So this will be this and this. Okay, so I need to mark regions. Oh my god, this problem will drive me crazy, man. I barely solved first. Yeah, that's insane. Okay. Closed. Okay, so yeah, let's see what do they want. I mean, I literally need like half an hour to just understand what we need to do. How many tiles are enclosed by the loop? Ah. Okay, so let's assume we have this, but uh, okay, so I'm chatting with one of my friends. Okay. I don't know, guys. Probably we'll finish with just part one. This god. Yeah. But at least I would like to understand the problem. Maybe I'll figure it out and we'll come up with the solution once I finish it. Okay, so we part to quickly reach the furthest point of the loop, but the animal never emerges. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. Uh, for example, how many tiles are contained in the loop? But this is one tile, if I understand correctly. Why did they decide that this is a different? So this entirety will be 1, this will be 2, and this will be 3. Where did they found 4? Okay, southeast and southwest. I below. Okay, this I found. I understand. The middle tiles, this marked all below, are not in the loop. Here's the same loop again with those regions. Here is the largest example. Okay, so we have a largest example. 1, 2. This feels like a coloring island map. Or is bounded. Uh, yeah, maybe it's not as tricky as I think it is. Yeah, let's see. So in this large example, 8 tiles are enclosed by the loop. Okay, so 1, 2. I guess this will be 3, 4, 4, 5, 6, 7, 8, 9, 10. Yeah, I'm not sure I understand how do they count them. Yeah, let's go once again. the above loop encloses merely 4 tiles. The two pairs of in the southeast and southeast marked I below, okay, in the middle marked as O below are not in the loop. Chin marked. Okay, so everything outside the loop will be 4. In both the above example, 4 tiles are enclosed by the loop. 1, 2, 3, and the outside 4. Or we don't count outside, I don't understand. Here's a large example. So we have this 1. This will be 2, 3, and 4. 5, 6, 7, 8, 9, 10, 11. Or we don't need to count like outside ones. Okay, probably they want only the inside one, so 1, 2, 3, 4, 5, 6, 7. I still don't get it. They count them. Yeah, let's see this first example. So 1, 1, 2, 3. So where do they get 4? Okay, I'm confused as hell. I don't understand. Grid of tiles. So these are tiles. So these are the tiles. How many tiles are contained within the loop? I don't understand what. Uh, 4 tiles. Middle tiles. Encloses merely 4 tiles. The two pairs in the southeast and southwest, southeast marked as I below. Okay. The middle. And where's the 4th? In fact, there doesn't even need to be a full tile path to the outside for tiles to count as outside the loop. Squeezing between pipes is also allowed. Here I is still within the loop and O is still outside the loop. Oh. Oh, so we need to count this too. Okay, got it. So only this two and this two. So this is 4. Now I understand. Okay, at least I understand what we need to count. Okay, so I guess this will be 1, 2, 3, 4, 5, 6, 7, 8. Okay. Random bits of ground, some of which are in the loop I, and some of which are outside of it O. In the loop. So this is outside. I have no clue. And this is in the loop. Okay, so probably the loop. It's weird. Whatever. So we need to count only I. 1, 2, 3, 4, 5, 6, 7. What the? It's not even 8. 1, 4, 6, 7. Where's the 8? Okay, so we have 6 here, 7, 8. Okay, so at least the count part is good. So what do we need to do? We need to find yeah, what we'll need to do, we'll need to color or change every tile outside the loop, and put it with something different, and just count things which are inside the loop. For how to do that? Good question. How to do that? How to do that? Yeah, it's a little bit too late, I guess. We should be done for today. We'll continue, I don't know, maybe tomorrow. We'll spend some time on this problem. It's interesting, but takes too much, and I'll think of a solution for that.